This is a website. Uh, from this website, you can access many classes, notes of many classes, PPT of many classes. Uh, from 6th to 12th, it will be limited in this, and it should be enough for you from 6th to 12th. Uh, these classes, PPT of these classes will be available here. I am going to search about math. This is class. Just come here and classes, select whatever class you want. For example, I want right now I want class set. Okay, class set. Next, then scroll it, and here you will here you will go. Now it is saying select a subject, so I want mathematics. This is a add. Now what will we get? This is a mathematics for class to 10th. What do you want? Do you want PPT or textbook or quiz or sample paper, question bank notes, video guides, live webinars, slip up of syllabus, lesson plans? Whatever would be requirement from this, you can select. I want a PPT. Then I will click over here, PPT. Now, now there are chapters, and whatever you want to study a chapter, just there is a mention chapter. Select this is rational, as you know. So I want to start from rational. Uh, where is rational number? This is. We have two links. We have two links. First, first of all, we will explore this link. Then we will say second link. Here we came on the PPT. It is working. You can wait. Reload it to sync the latest version, including all of your changes. Reload. Here we have chapter number 1, rational number, class 8, mathematics. Mathematics. Uh, this was one slide. This is one slide. First slide. Then we have this next slide. Then let's see how much numbers of slides we have. So we have 17. We have 17. We have 17 slides. In this slide, you are understanding what this is chapter number 1, and name of this lecture is a rational number. This is a standard 8th, and subject is mathematics. It's a me. It's a me. In this video, it's a me. Now let's start. Let's start with the second slide. Here, numbers everywhere. Everywhere you can realize numbers. Everywhere. Even in front of you, there are a lot of subjects. There are a lot of things. That things can be counted. Is a number. We use numbers in our day-to-day life. Yes. When it comes to where do we use, then answer would be indirectly and directly. We use a lot of numbers in our daily life. It is a content. Whether you are scrolling, whether you are running your mobile, whatever you are doing. As you wake up, you sometimes in a one day you go to shopkeeper, then you pay money for materials. So when you pay money, then you count money. This is where you realize the numbers. Now, right now, I told you we have 17 slides. So 17 is a number. How much? It would be better to say that yes, it is useful, not useless. Numbers are useful, not useless. It will not be better to ignore it. This is what I am saying. If you are afraid of mathematics, then it's your fault. It's your fault, not mathematics. You have to understand carefully. If you are afraid of this mathematics, then in details we will be discussing it. And remember, this is a basic. It is not advanced. From here, basic starts from this standard. Now, in first sentence, we use numbers in our day-to-day life. Let's have a look at those scenarios. First day of the week. Here we are saying first day of the week, which means first day of these 7 days. First day of these 7 days. This is what we are saying. 1 month. In one month, how much are days? You would say 31, 30. These are numbers. Next we have five-seater car. Five-seater car is a number. 1 liter of a milk, one is a number. One full ticket in a bus, one is a number. One bus is a number. Two buses is a number. I have a person. This is also a number. A person. A one. Next, if you see the numbers above in these scenarios, we can see that we have used natural numbers. As the name suggests, they are used naturally by people for counting in day to day to use from 1 till infinity. Yes. Whenever we are counting anything will be known as natural. We count naturally. Right now I have this one. I am counting naturally. I can see yes I have a object. I am saying this is one and one more. This is two. There are two pins. So I am able to count this naturally. That's why numbers are. That's why when we counting numbers are also natural numbers. Counting number are also natural numbers. Next, we all know how these numbers are represented in the number line. We will draw a number line. Then natural numbers we will plot on number line. We will say don't worry, just to draw a number line, and then there between would be 0, and then this side would be 1 2 3 till the infinity. This side would be right side would be positive numbers and left side should be negative number. This is how we represent numbers. But when it comes to natural number, then on the number line we can observe natural numbers. On the number line we can observe integer number, rational number, and details about it we will see. Now we are starting with natural number. This is clear. This slide is next. Let's see some more examples. We understood natural numbers with some examples. Let's take some more examples to understand another numbers. How about half liter of a milk, which is 1 upon 2? This is a half. This is considered as a half, or say 3 upon 4th liter. What do you think about it? Is this number is 1 upon 2 number or not? Of course, this would be number. If you think it carefully, then your mind would say yes, this is a number 1 upon 2. We are taking half of 1. This is what we are taking, half upon 1. Half of 1. So this is also a number. Next, how about an half ticket in a bus travel, which is a half? Again, half. This is also number. What would you say? You would say this is a half. Just a half of a one. Half of two would be what? One. Half of three would be what? 1.5. Half of four would be what? Two. All these are numbers. How about a 3 upon 4th pant? A casual wear. Here we are saying third portion of a fourth. One portion is a not, we don't have one portion of the fourth. We have third portion of the fourth. This is what we are saying. When we say 2 upon 4, then we are saying we have a fourth. We have a fourth. Now, with example, I would like to tell you about 3 upon 4, 1 upon 2. I have right now, I have two, two pens. I have two pens. Hold on. This is a group of pens. Now, what if initially I have four pens. Now, I remove this one. Now, how much numbers of pens? Uh, I have three. So can we say one is a gone? One is a gone. So we have three pens of four. This is what is the meaning of a 3 upon 4th. Now next we have, if you look at the number format, here it seems different from what we know already, integer, whole number, natural. It seems different. 1 upon 2, 3 upon 4. This is a different. It seems different from the natural number, from the integer, from the whole number. Whole number is just what? 0. It starts from 0 till it keeps go till the end. Natural number, it starts from 1 till the infinity. Integer is what? It takes a negative number, zero number, positive number. When it comes to integer, whole, natural, then we don't take 1 upon 2, 3 upon 4, 10 upon 20, 20 upon 10. Like that, numbers we don't take. So this type of numbers, what will be? These are numbers also. 3 upon 4, 1 upon 2, these are also numbers. So what kind of these numbers are? Answer would be rational number. This type of numbers would be considered as rational number. Rational number says that a number which is upward and another number which is downward. So upward, downward is a rational number. P upon Q. Denominator, numerator, numerator, denominator. This is what? Rational number. Rational number looks how? 2 upon 1, 3 upon 4. This type of number will be rational number. Name of this 3 upon 4, 1 upon 2 we will call it a rational number. Just one is a whole number, one is a natural integer. But when it will come to 3 upon 4, then what would you like to say? Would you say 3 upon 4 is a natural? No. 3 upon 4 is a whole? No. 3 upon 4 is an integer. Would you say? No. Instead, you would say this is a rational. Let's explore it. Now we have its of form numerator denominator. Upward number would be numerator and the downward number would be denominator. Remember always numerator denominator, numerator upon denominator. It's a form of the form numerator upon denominator. This form is called rational number. Whatever a number which is a numerator upon denominator is a rational. That's it. That's it. This is how we represent a rational number to show a rational number. Now we are able to move ahead. Formal definition of a rational number. Formal would be what? P upon Q. Number which can be written in the form P upon Q. P upon Q. P would be numerator and Q should be denominator. So a number which is in the form of a P upon Q, but remember Q should not be equal. Q should not be 0. Q should not be 0. Then it will be definition of a rational number. Q should not be equal to 0 is called a rational. This was a formal definition of a rational number. Now we are next we have 2 upon 3. These are examples. Minus 6 upon 7. Here we can see P upon Q. 2 is a numerator, 3 is a denominator, and 2 upon 3. This is how we call it. In this you can see P would be integer, Q should not be in 0. That's it. Q can be natural, Q can be integer, but Q should not be 0. Here 3 is not a 0. That's why it is 2 upon 3 is a rational. Minus 6 upon 7. Minus 6 is an integer. 7 is a natural. It is also an integer. But here in place of a denominator is not a 0. Now numbers 0 to 4 can also be written as 0 upon 1, 2 upon 1, 4 upon 1. Yes, this is also true. If you take a number 0, 2, 4, 6, 7, only 1, not a denominator, only 1, numerator 1. Then remember, it is also represented as a 2 upon 1. 1 would be hidden as a denominator. 1 always it would be hidden. Okay, this slide is also clear. In this you understood many formal definition of a rational number, and you saw that yes, a just a number 2, 4, minus 4, minus 6, minus 100. These are numerators, and denominator in the place of a denominator 1 would be hidden. 1 would be hidden always forever. Now next a lot of many example and uses of rational number in a real life. Let's visualize in a real life. When you complete assignment half portion, you say that you completed half or 50%. You say I have completed my project 50%. This means half your work done half. In commercial we see 90%, which is a 90 out of 100. 90 then percentage is just 100. 90 of 100. Doctor prepare this toothpaste. This work will work at 90%. Marks awarded in a test like 20 out of 25. That means 20 upon 25. You go to 25. You didn't go to 1. you got 24 from 25. This is how you uh, say like that. Rational number uses is not only limited to this. Yes, we saw this real life example. These are not enough. There are a lot of real examples of these examples of a rational number in a real life, and it will be impossible to write here. So even we can say it is arithmetic. Rational number use is okay. We will see how they are used to solve a mathematical equation. Don't worry, we have some questions based on this rational number. Uh, Something could be there would be suspense, something would be twist. Let's see next equation. Now we have a simple questions based on the rational number. Here equation x plus 2 is equal to 13. If we solve it, then what would be value of x? Of course 11. X is 11. 11 plus 2 would be 13. Is solved when x is 11. 11 is a natural number. Yes, it is also integer. It is also integer. 11 is also integer. It is also unnatural. Now x plus 5 is equal to 5. So here would be what? X will come out as a 0. 0 is an integer. It is also 4. It is 0 is not natural. That is how we identify any number. Can you say 0 is a natural number? No. This is a integer. It is also whole. Now next we have 2x is to 3. Now what about this? This is something else. Here is a twist. Here is a twist. We were able to tell that yes, here upward we were able to tell that yes, 11 came and it is a natural. Now in the next equation we saw that yes, 0 is coming as a x. So 0 is an integer, 0 is a whole number. But what about this? 2x is equal to 3. Here we will not get like that number 11 0. Instead we will get 3 upon 2. Now what would say? What kind of number is this? 3 upon 2. Of course this would be rational, because rational number, meaning of rational number is what? Just p upon q, where q is not equal to 0. Okay, so x is a rational number. This bring us to the conclusion that we need to have a collection of numbers of the form p upon q called rational number, and their use in mathematics and in day-to-day life. There are a lot of uses of a rational number in our daily life, and this brings us to the conclusion that we need to have a collection of numbers of the form to p upon q called rational number. When we will be solving, we will when we will hold on. When we will be solving a lot of equations, then a lot of numbers we will be realizing. For example, natural, integer, rational number, a lot of number we will be realizing. Now here, okay, this slide is clear. Now next we have a number line. Since we have learned a new set of number, which was a natural, whole, integer, and we included a rational number. This is a set of number. There are more apart from this. There are more numbers. We will explore those numbers that we didn't explore. We will explore in separate lecture. Let's see how they are represented on number line. Whatever we saw, we explained numbers. Let's see how to represent those numbers on a number line. How would you represent 3 upon 4 on the number line? You were able to represent 2 3 0 minus 4 on the number lines, but what about 3 upon 4? 3 upon 4, how would you represent? So first of all, you have to draw a line which should be horizontally straight. Then just between this, at the medium of the line, just draw a small line and write a 0. This would be 0. Now right side of the 0, this side would be positive and left side of the 0 would be negative. Now we want to represent 3 upon 4. Then how to represent it? So answer would be, just take uh, just take 1 upon 4, 2 upon 4, 3 upon 4. Then the next would be what? 4 upon 4. 4 upon 4. So 4 upon 4 is just 1. So 1 can be called as a 4 upon 4. So this is a proof that yes, 3 upon 4 would come here over here. Next we have 4 parts will be representation of a 3 upon 4. M D third part of the, this was just a little bit knowledge of how to represent rational number in details. Let's explore this. Next is, in this lecture our focus will be on completely on rational number. Don't worry, I am not ignoring anything, just slowly gradually we are understanding. Since we have learned a new set of numbers, let's see how they behave for a properties which we have already learned. These are properties. We cannot ignore this. Without this, there would be impossible to call anything number, to represent anything number. Uh, we have a four: commutative, associative, distributive. Then next is a closure. It will be more important to understand all this so that our basic can be strong. It will make your basic strong. It will make your basic strong if you understand it carefully. Commutative. Commutative. Remember, these are properties. These are properties of a number. And when it comes to properties, you know what is the power of a properties of a something. Let's start from community property. Here we have this community properties. Changing in the order of the number in addition or multiplication will not change the result. Cognitive property of addition states 2 plus 3 is equal to 3 plus 4. Now, in my language, I would like to say about cognitive properties is that in left side, in left side, there are numbers. For example, 2 plus 3. Okay, 2 plus 3, and here same in the right side we can write 3 plus 2. You can change place of number 2 plus 3, 3 plus 2. Answer would be same, result would be same. This will happen, result would be same when we have community property which means addition and multiplication. When we add numbers, when we multiply number, then both sides we can take same numbers, we can place the numbers, but result would be same. So this discussion is known as commutative properties. Commutative property of a multiplication states 4 into first here 2 plus 3. This is addition, 4 2 plus 3. In other equation we can write it as a 3 plus 2. In a result, there would not be any kind of error. Next, in the case of multiplication, 4 multiple 5. In other side, we can write 5 multiple 4. We can change a place of numbers. but there would not be any changes in the result. So here remember, there is a nothing changes when we change your place of our numbers in both sides. Then this type of a properties is a commutative. This is true. This is done. Now next, okay, commutative, commutative, commutative property. Clear, pronounce it. Okay, pronounce it clear. Commutative property for rational number. Commutative property holds good for addition and multiplication of rational numbers. Adding two rational numbers in any order gives the result as below. For example, 1 upon 4 plus 3 upon 4. Here we took a rational number. We didn't took a direct a simple number 2, 3, 4, 5, not like that. We took a rational number. So here 1 upon 2 plus 3 upon 4 is equal to 2 plus 3 upon 4. So answer would be what? Answer would be what? When we will solve, then hold on. We have one side 1 upon 2, then plus 3 upon 4, then plus 3 upon 4. Hold on, one thing I want to do. Now here 1 upon 2 plus 3 upon 4, this is the algebraic equation. Here we can after solving this we will get 5 upon 4. Of course we will get 5 upon 4. Now next we have 3 upon 4. Just we changed places of a number. 3 upon 4 plus 1 upon 2. Now in that case what will happen? We are getting same result, 5 upon 4, same result. So yes, this is a proof of yes, when we will add a rational number, when we will add two or more rational number, and we have two sides, numbers are same, but just we are changing on places of number. In that case what will happen? Result would be same. But remember, if you are adding, then result would be same. Result would be same. It will happen with the same multiplication. Therefore 1 upon 2 plus 3 upon 4 would be equal to 3 upon 4 plus 1 upon 2. Okay, done. Now next, multiplying two rational numbers in any order gives the same result as below. Yes, always remember, if you are multiplying any rational number or a simple natural number, integer number, uh, if you are adding, even if you are adding, then in both sides numbers are same. Numbers are same in both sides. Then in that case you will get the same result. You can change a lot of times places of numbers. There would not be any kind of effect in a result. Now we have examples of multiplying two rational numbers. Let us consider the rational number 3 upon 4. We are taking two rational number 3 upon 4 and 5 upon 7. And in both sides we are this is same 3 upon 4 multiple 5 upon 7. Now after solving this 3 upon 4 multiply 5 upon 7, this will give us 15 upon 8, 15 upon 28. Then next we are changing, we are replacing 3 upon 4 by 5 upon 7 and 5 upon 7 by 3 upon 4. In that case what will happen? Same result we will get. 5 3 is 15, 7 4 is 28. Therefore, we can say 3 upon 4 multiple 5 upon 7 is equal to 5 upon 7 into 3 upon 4. But when it will come to subtraction and division, then there would be something effect. There would be changes. Let's just say this was about commutative property of numbers. Now, associative property. Associative property. Take any three rational number A, B, C. Firstly, add A and B. First of all, you add in A, then B, and then add C to the sum. In that case, in that case. So here we have three numbers. First of all, we will add A plus B. Then, after adding this, we will add with C. Now this time add B and C first and then A to the sum. Yes, in this case, what will happen? Answer would be same. Is A plus B plus C and A plus B plus C same? Yes, yes, both would be same because of we have addition. That's why we have addition. But if we have subtraction, then result would not be same. Both would not be same. Yes, and this is how associative property works. Associative property works. Associative property, which means if we take two or more rational numbers, then result would be same. It states that you can add or multiply numbers regardless of how they are grouped. For example, given numbers are 5, then minus 6, add 2 upon 3. 2 upon 3. Then here 5 minus, okay, then plus minus, then here 2 upon 3, then here 16. Both are same. In both the groups, the sum is the same. Addition and multiplication are associative for rational number. Subtraction and division are not associative for rational number. This is mean if we are adding and multiplying the rational numbers, then result would be same. But if we are subtracting or dividing the rational number, then we will not get associative numbers. We will not get a same result. Distributive property. Distributive which means a distribution. Distributive property of multiplication over addition. Multiplication of a rational number is a distributive over addition. If A plus A upon B, C upon D, and if A upon F are any three rational numbers, then A upon B x C upon D plus Z upon F would be what? A upon B multiple C upon D plus A upon B multiple E upon F. What is happening? We are multiplying this A upon B by sum of C upon D plus E upon F. In other side, what is happening? A upon B multiple. First of all, we are multiplying both. So what will happen? Both will be same. Example, 1 upon 3 multiple 2 upon 5 plus 1 upon 5. 1 upon 5. So here we can either multiply this with first 2 upon 5, then we will apply addition, then we will multiply 1 upon 3 by 1 upon 5. 1 upon 3, 3 upon 5, we will get 1 upon 5, 1 upon 5. And same here, we will get same answer, 1 upon 5, because of we are adding and multiplying, that's why we are adding and multiplying. That's therefore multiplication is a distributive over addition. Distributive over addition. Therefore multiplication is a distributive over addition. Distributive, which means we distribute rational number, we divide rational number, we are multiplying as well as adding. This was about distributive property. If you didn't get any idea regarding this, don't worry, just you can understand it as a first time. Let's say you just saw this, that's it. This was enough for you if you are beginner for this. Then now next we have a distributive property of multiplication over subtraction, which means 1 upon 4, then minus 1 upon 4 multiple, then bracket, round bracket, then 4 upon 5 minus 5 upon 6, then close bracket. That is how, if we take like that numbers, if we take, if a upon b, c upon d, and a upon f are any three rational numbers, then in that case what will happen here? What will happen here? As you can see, we are getting 1 upon 15, 1 upon 15 over subtraction. So therefore multiplication is a distributive over subtraction. Same result we will get even we take a subtraction in this, but the subtraction is with the multiplication, addition was with the multiplication. Close property of rational number. Close property of rational number. The sum of any two rational number is always a rational number. This is called closure property of addition. For example, 2 upon 9 plus 4 upon 9, we are getting a number which is in form of 6 upon 9. It can be simplified. At the end we will get 2 upon 3. This is what is a rational number we know. If we are getting a rational number by after adding the rational number, then this will be known as, this property is a closure property. The difference between any two rational is always a rational number. Example, yes, again difference. If we are subtracting a rational number from other rational number, then again if we are getting a rational number, it means it will happen if you take rational numbers are closed under multiplication. Division of a rational number is not closed because all integers are not divisible by 0. Okay, we will see it later. Now next we have a definition of additive inverse. A definition of additive inverse. The additive inverse of a number line is its a mirror image. Just a mirror. Whatever images we see inside the mirror, we see that distance between them are same. Distance of a object from the mirror would be equal to distance between the image and the mirror. This is what happened. Same here would be. Here would be. In both the side, measure would be same. Just we take a negative number so that we can tell yes, this is the direction, and positive is this is the direction. If a number is a positive, its additive inverse is a negative, and if a number is a negative, its additive reverse would be positive. Just a negative of a positive, just opposite of a positive number would be negative. Just opposite of a negative number would be positive. Just opposite. Additive inverse can also be defined as what you add to a number to get. For example, plus 5 plus minus 5 would get, you will get 5 0, because of, first of all, you will go from 0 till the 5, till the 5. So then till the 5 you went, then again you will have to take back step, how much, minus 5, then you will reach to the 0. That is how 0 comes. For any rational number, the additive refers to the negative of the given rational number. For example, minus 3 upon 11, the additive inverse will be, so of course, just our focus will be on the addition, on the sign. Is the sign add or subtraction? For example, here we have a minus 3, minus, we have a minus, so just convert this minus into addition. We will say that yes, additive inverse of minus 3 upon 11 would be just 3 upon 11. Now you tell me, what would be additive inverse of 3 upon 11? You would say minus 3 upon 11. What would be additive inverse of minus 1 upon 2? You would say 1 upon 2 would be additive inverse of minus 1 upon 2. This was very easy. Now, in this we saw what is the additive inverse, how to convert a additive inverse into, how to convert a rational number into additive inverse. We have seen. Now next we have identity of a rational number is 0. If a upon b is a rational number, then a plus b, a upon b plus 0 is equal to 0 plus a upon b would be what? Would be what? Just a upon b, because here we are not multiplying, here we are adding. That's why we will not get a 0. We will get a upon b. When we will multiply by 0, then of course we will get, when we will multiply 0 by rational number, then we will get 0. Do you want to say multiplicate identity of a rational number is 1? A upon b is a rational number, we are multiplying by 1, then 1 upon 1 multiple a upon b, what would be result of this? Just a upon b, because here we are multiplying a rational number by 1. That's why if you multiply a rational number by 0, then of course you will get 0. But here 1 is coming, we are multiplying a rational number by 1. That's why a upon b is as it. Now next we have a multiplicative inverse of any rational number is its reciprocal. Itself. What is the reciprocal? It will be it is very important to understand the reciprocal, because in the next standard this would come as a small brother, So reciprocal is just what is it? As we saw about additive inverse, same here, reciprocal is something different from the additive inverse. Just we convert a denominator and numerator. Just we change places of numerator and denominator of a rational number. That's it. This is a reciprocal. For example, we have a upon b multiple b upon a is equal to 1. Now in this case, what is happening? From my example, I would like to explain about reciprocal. You have a rational number. Let's just say 5 upon 4. Let's just say 5 upon 4. 5 is a numerator and 4 is a denominator. Now reciprocal of this of 5 upon 4 would be just 4 upon 4. 4 upon 5. Initially we had 5 upon 4. Now we have what? 4 upon 5. This is what is the reciprocal of 5 upon 4. Just to we replace, just to we change places of numerator and denominator to represent a reciprocal. Here 1 upon 5. So reciprocal of this 1 upon 5 would be 5. And reciprocal of a 5 would be 5 upon 1. That is how we convert any number into rational number. So finally it is done. Finally it is done. Now next, let's see. Mhm. Next link, we were here. Next link, we have this link. Next link, we have this. This is a PDF. This is what is a PDF, rational number we know. And here you can see whatever we discussed are same here. In initial question, how do you know if a number is a rational number? Two kinds of real numbers, rational number, irrational number. Rational numbers are like that. We have explained numerator, denominator. Uh, yes, this is also clear. Rational number, natural number, whole number, integer number, rational number. A rational number, how to represent a rational number on a number line. Okay, okay. Properties, for properties we have discussed its distributive, commutative, associative, identity properties of 1 and 0. This is also done, isn't it? We will explore it someday. Don't worry, we will explore. Here we realized that yes, both links are same. Both links are same. Just PPT is a different PPT. Chapters are same. Discussions are same. Just a way of way of explanation of rational number chapter is different, but chapter is the same. Topics, you can say topics are same. Now we are able to move to the next chapter. To the next chapter. Next would be linear equation in one variable. We have two links, and it's up to you. Whatever given a PPT you want to select, you can select. I am observing how much numbers of slides we have. Of course, we have 12. Now let's see what is inside the second link. What is inside the second link? This. We have a PDF. Even we can convert a PDF into PPT. Let's see. Open with How to convert any PDF into PPT? You can see, you can observe. Here we have this. This is a PDF. This is PDF. Let's convert it into here. Convert option is here. Here we have options: PDF to Word, Word, PDF to Excel, PDF to PPT. This option, and it will convert our PDF into PPT. That is how PDF is converted into PPT. Just you will have to take a subscription of this app. It's working. You can wait. Why? Now it is done. You can play here. You can play over here. Here we have this. Example 1. Example 1. 5x plus 1 is equal to 2x plus 7. We are saying both sides are same. That is what we are saying. Here we take ax. We take ax. Example number 1. Here we have ax variable. We have ax variable which can in the place of x alphabet, number can be anything. Here number can be anything, we don't know, because it changes every time, every step it changes. And here we are saying both sides are same, so we are going to check, we are going to find out what would be number in place of x, in place of x. This is what we are going to find. So this leaves us with 3x is equal to x, 5x, then here 2x, we have 7, 3, 3 4 3 7 and 2, 2x. Here you can visualize this figure, which means this side we have 5x, 5x box, this side 2x, 1 is clear and 7 is also clear, 2x. In this side 3 to 5 and 1. So here you can see green boxes are representing a this is a skin color of boxes are representing constant number. A skin color of boxes are representing constant number, and a number which is with a variable will be known as something constant. I didn't remember. This leaves us with 3x is equal to 6, which means that x is equal to 2, 3x is equal to 6. So of course answer would be 2. Answer would be 2. To check if this is correct, just put the value of x in the place of here whether if your answer correct or not, then just put value of x in the equation. Both sides are equal, then you have to, then yes, it is done. Your answer is correct because of both sides are same, that's why. Example to solve this. Here constant numbers are, we have how much, we have 10 boxes. In this side we have 2 boxes, and green boxes are 5, and in this side we have 3. 3x, 3x, 5x, 5x plus 2, 3x, 5x, 2x, and then here 10 minus 2, 8. Of course x would be 4, x would be 4, 4 here and 4 here. Worksheet solution. These are questions. These are questions. And this perhaps we will get a concept. This is not concept. Equation. Then meaning of equation is what? Use the equal sign. Yes, in this we will have a understanding of a concept of lecture this lecture. This lecture is about understanding of a concept of this lecture. How to solve linear equation. First of all, we will explore this PPT, then that PPT. This is chapter 2, and name of this lecture is linear equation in one variable. Class 8. Subject is mathematics. Now equation. What do you think about equation? Equation, which means equal. You can consider it as a equal. If we have two sides, so both sides should be equal. If both side does not don't have a equal, then we will do equal those sides. Meaning of equation is a mathematical expression that states that two quantities are equal. Two quantities are equal. Two quantities are equal in one side. Quantities in one side is equal to quantities which are in left side, in the right side. Use the equal sign. If you are taking equation, of course there would be a equal sign between. So when we have equal signs, of course we are taking two sides, left side, right side. Between this would be equal sign. This will be important to solve to show equation. Now next we have here this is the example. In one side we have quantities, two numbers, 2 plus 8. This is in one side, and here we are applying a equal. By applying this equal, we are saying one side is equal to another side. 10 is another side. This is another quantity. So both sides are equally. So this is what equation. Both sides are equal will be considered as an equation. Same with another example, 10 minus 5 is equal to 5. Both sides are equal. Both sides are equals. Now next, this is done. Types of equation, let's visualize. Linear equation in one variable. Here we will take a variable is just alphabet. You take alphabet, so that you don't know unknown number, that's why you take alphabet. Now if you take alphabet, so remember, in place of alphabet, number can be anything.